Xi. I'm from Xi'an University. Today I will introduce our work named Wasserstein Style Distribution Analysis and Transform for Stylized Image Generation. I will introduce the background firstly. Stylized image generation aims to generate images that are consistent with the reference style and align with the conditional test property. Recent optimization free methods control the stylized image generation process by modifying the internal features of the unit. There are two fundamental changes to be tackled for such approach. Since the different model contains various features, which features should be modified for stylized image generation. Given the features, how to modify the features to generate the desired style. For the first challenge, we propose to systematically analyze the sensitivity of various features in attention blocks to style. We quantify the discrepancy of feature distributions caused by style based on Wasserstein distance. The idea is that if style change causes a significant variation in the feature distribution, then that feature contains meaningful style-related information. We construct a dataset of style-perturbed props. We use GPT to generate category and style descriptions to construct two sets of props, the content only and content style prop sets. Using these props as text conditions, we can extract distinct features of style variation. We then quantify the sensitivity of these features to style using the Wasserstein distance. The Wasserstein distance between two Gaussian distributions has a closed form solution and can be calculated using the mean variance of the features. To measure the style sensitivity of features, we extract features with the same content but different styles and calculate the Wasserstein distance between their distributions. To mitigate the scale effects, we also extract the Wasserstein distance between features with different content but the same style. We define the style sensitivity metric as a ratio. A larger ratio indicates a more sensitive feature to style. We analyze features extracted using three popular latent different models. The results across all models show similar patterns. For the input value and output features of the self-attention module, the distribution differences due to style changes are much greater than those due to category changes, indicating that these features are more sensitive to style and significantly affect the style of the generated image. For the second challenge, we aim to use the optimal transport plane to transform the feature distribution of the generated image to match that of the style image. Given features f and g, if f follows distribution p, g follows distribution q, p and q are modeled as Gaussian distributions, then the optimal transport plane from Gaussian distributions p and q has the following form. When covariance matrices are diagonal, this distribution transform degrades to the form used in anti-in, replacing the mean and the variance of each channel in the generated images feature with those in the style images feature. This inspires us to further design a channel-wise Wasserstein distance to measure the distribution discrepancy of each channel, allowing us to adaptively select channels with stronger style significance for distribution transform. We employ a threshold tau to select channels with smaller distribution distances between style and generated features for transform, while keeping channels with larger distances unchanged. Here is the set of selected channels. We show a simple but efficient algorithm for stylized image generation. We validate the effectiveness of one method on evaluation dataset. We first implement a method using ST-child as the base model. As can be seen, compared to other methods, our method generates high-quality stylized images. Not only is the style consistent with the style reference image, but it also effectively reduces content leakage problem. Our method can also be extended to the ST3 model based on the transformed architecture. Our method also outperforms other methods in terms of quantitative indicators. At the same time, our method does not require pre-training or test time optimization and has high generation efficiency. Our method can also be expanded to more application scenarios. For example, it can be combined with other control book generation methods based on different models to generate stylized images with controllable content. Our method can also generate images that blend two styles. This all thanks for attention.